Alright guys, so let's go ahead and take a look at the bones and bony landmarks of the forearm and the hand. So continuing from the lecture on the shoulder and the arm, we're looking at the bottom or the distal half or distal part of the humerus. So this is right here, our humerus. Again, this is going to be our humerus up here as well. Now, keep in mind, this is going to be the anterior side or anterior view of our forearm and hand. So this would be our palm facing towards us, and this would be the posterior view of our forearm and our hand, this being the back of our hand facing towards us. So let's look at the humerus first and see some of these different landmarks we're talking about. Now, the first one we're going to look at is this mark right here, this little particular part here, which is a little rounded knob called the capitulum. The capitulum, almost like catapult looks or sounds like capitulum. The capitulum right here is the part of the humerus that's actually going to articulate with this radius to form the humeroradial joint. The next landmark we're going to look at right here is what we call the trochlea. This is the part of the humerus called the trochlea. It's kind of like a little hourglass shaped type of structure, and it runs from the anterior part towards along the back here, along the sides. And this is what the ulna actually glides with or glides in, kind of like a train track. It's like the tracking of the humero-ulnar joint that is the movement of our elbow, that flexion and extension of our elbow. So this is the trochlea of the humerus. Now, the other landmarks of the humerus, we're going to sum three components up. So let's look at this side right here. This would be what we call the lateral side of our arm, and this would be the medial side. Medial being closer towards the midline of the body, lateral being further away. We're just looking at this one. So medial side, lateral side. So we have two condyles, which are like rounded knuckles of the bone. We have a medial condyle and a lateral condyle. Now, on each side of the humerus, we also have a lateral epicondyle, epi being a word meaning it's on top of, so this would be a condyle on top of the condyle, and then a lateral supracondylar ridge. Supra meaning above, so this is a ridge above the condyle on the lateral side. And then we would have the same things on the medial side. We would have a medial epicondyle, that would be a condyle on top of the condyle on the medial side. Then we have a medial supracondylar ridge. Again, a ridge above the condyle on the medial side. So to avoid putting all these crazy little terms out there, we're going to sum up these three on each side, all six, right? We're going to sum up the three landmarks on the lateral or medial side into just saying they are the lateral or medial condyle. So by that, I mean that we're just going to look at that when I say lateral condyle, I also might be referring to the lateral epicondyle or the lateral supracondylar ridge. We're grouping up these three landmarks into one. And then we would do the same thing on the medial side. So when I say medial condyle, I'm referring to the medial condyle or either the medial epicondyle or the medial supracondylar ridge. So remember that when I'm going through and I'm just keeping it simple with the muscle attachment sites. Now, the next few things we're going to look at is some of these major bones. We've seen the humerus. We know the margins of the humerus. Now let's look at these bones. So the lateral bone of our forearm, the bone on the outside of our forearm, is called the radius. This is the radial bone. This is the radius. So this is the radial side or lateral side of our forearm. and this would be the radius as well over here. The medial bone right here is what we call the ulna. Again, this would be the ulna over here. So this is the ulnar side of our arm, or the medial side of our forearm. So let's look at a few landmarks specific to just these bones. Let's start with the radius. The radius is easy. Right here, this little rounded part right here is what we call the head of the radius. So the next landmark we'll look at is this, which is the radial tuberosity. We might not pay too much attention to this, but just to list it, this is the radial tuberosity. This is the projection of the radius. Down at this other end of the radius, this big margin here is where it actually reaches out and touches the carpal bones, but we have the styloid process, which is just a little extension off of the edge of the radius here. And then, of course, we have the shaft of the bone itself. So to recap, we have a head, we have the tuberosity, we have the shaft, and we have the styloid process. Looking at the ulna, well, the ulna, we have this little notch right here, this little projection right here called the coracoid process. This would be on the anterior part. Now, on the back, the posterior part of the ulna here, we have this big landmark right here called the olecranon process. That is the olecranon process, which happens to be your elbow. This is the big bone. If you were to touch your elbow, this is what we call the elbow. Now, we'll see that for the humero-ulnar joint, this part of the the ulna here has this little kind of hook shape like this. And so this is the groove that's going to articulate with the capitulum here of the humerus to make the humero-ulnar joint. So this little indentation is what we call, which you can't see from the depictions here, this little indentation is what we call the trochlear notch. So this is the notch of the ulna that articulates with the trochlea of the humerus. So of course we also have a shaft to this bone as well, and then we have another styloid process. So coming down into the wrist here, we have a few bones here to look at. So if we look at these carpal bones, we can notice that now, of course, this is not a perfect depiction of what the carpal bones look like. We have a row and then another row. We have a proximal row because it's closer towards the body, and then a distal row because it's further away from the body. So again, we have a proximal row and a distal row on this side. Then, of course, we have a lateral side and then a lateral side, and then we have the medial side. So looking at the carpal bones, we're going to start with the proximal row on the lateral side and work our ways medial. So this bone right here would be what we call the scaphoid. So I like to think of scaffolding, the scaphoid, because it's the start of our building of the carpal bones outward. So the scaffolding. On top of that scaffolding, we're going to have this little landmark called the lunate. So we're going to imagine that this scaffolding is holding up a crescent moon, a lunar crescent moon. So the lunate. Then we have here the triquetrum. Again, no major association there, just the triquetrum bone. And then the last bone on the outer edge, or excuse me, the medial edge here in the proximal row, is what we call the pisiform. I like to think like Pisces, form. So Pisces, form, like formal wear, I think of a fish wearing a suit and a tie, and maybe a little top hat. He's a formal fish, with a monocle too, right? Because he's a formal fish. Pisiform. So to recap, we have the scaphoid, lunate, triquetrum, and the pisiform. So from lateral to medial in the proximal row, scaphoid, lunate, triquetrum, and the pisiform. Now in the distal row, we have, again, we're going to go from lateral to medial. We have the trapezium, like the flying trapeze, right? The little flying trapeze. And we have a gentleman on the flying trapeze. And he's going to jump from trapeze to trapeze. So the trapezium. Then we have the trapezoid, which is in the shape of a trapezoid. Very simple. We then have the capitiate. Think of like decapitate, so I think of like a French murder device called the guillotine. Going to cut someone's head off. So capitiate or decapitate. Capitiate. Then on the very end we have the hamate. And I like to think of a ham sandwich with a big bite taken out of it. Nice delicious ham sandwich with a fishing hook in it. Why? Because this fishing hook is representative of a particular landmark on this bone, which is the only carpal bone we're going to look at that has a landmark we care about called the hook of hamate. So the hamate has a hook. So again, to recap, we have the trapezium, the trapezoid, the capitiate, and the hamate. Now, the trapezium is very particular because it actually forms a joint with this particular bone we'll see in a second to form the thumb joint, which we'll see is known as the saddle joint and does particular actions that we'll see when we talk about the joints. So the next bones we're going to talk about are these bones. We're going to look at them all together because we can just group them up. We call these bones the metacarpals. The metacarpals because they come off of the carpal bones. These bones would be the long bones that are in the palm of your hand. These are the metacarpals. So when it comes to these bones, we're only going to look at three landmarks. We look at this end, we look at the center shaft, and then we look at the counter opposite end. So this end right here is what we call the base. This is the base of the bone. Then we have the central shaft. And then we have the head of the bone. So be pretty particular in what occurs here and what bones are articulating with. So again, the base, shaft, and head. And this would be consistent with all of these bones. As a matter of fact, it's actually consistent with all of these bones too down here, but these bones that we'll look at go by a different name. So these bones right here would be what we call the phalangeal bones. These are the bones in your finger. Now, obviously in the thumb, we only have two. So we have a proximal and a distal. But in every other finger, we have a proximal, we have a middle, and a distal phalangeal bone. And then, of course, we have joints in between any of these, which we'll look at here in a little bit. So just to make it clear, we want to be specific of what bones are meeting for these joints. So we would have right here, it would be the head of the metacarpal touching the base of the proximal phalangeal bone, in this case of the second finger. We always orient our fingers starting with, obviously we know we don't consider the thumb to be a traditional finger, but we call them digits, but we always number our digits starting from the thumb. So this is the first digit, second, third, fourth, and then fifth for the pinky. The fifth is always the pinky, the first is always the thumb, and then plan accordingly. So just again to recap, be specific. So we would have the head of the metacarpal articulating with the base of the proximal phalangeal bone of the second finger to form the metacarpophalangeal joint. And then we would have the head of the proximal phalangeal bone of the second finger articulating with the base of the middle phalangeal bone of the second finger for the articulation of the proximal interphalangeal joint here. So with that said, let's go ahead and take a look at those joints and their movements in a little more detail. So now that we've had an introduction to the bony landmarks, let's go ahead and put those bony landmarks together and form those joints. So the first joint we're going to be looking at is where the radius meets the humerus. And we call this, get ready, it's tricky, the humeroradial joint. The humeroradial joint. So what exactly is touching to make the articulation here? Well, we have the head of the humerus here touching the capitulum of, the head of the radius touching the capitulum of the humerus there. So the head of the radius and the capitulum of the humerus meet and they form the humeroradial joint, which we say is a box type of ball and socket joint. There is a little depression there, is a little bit of a ball here from the capitulum and a little bit of a depression on the radius itself, but it is typically a gliding plane joint, a gliding plane or a synovial gliding joint there. So what exactly happens, what movements occur here at this joint? Well, we can see that obviously at the elbow we do have to flex, which means our elbow is coming here, our hand is coming towards our shoulder. This is flexion at the elbow. Here's our elbow and it's flexing. This is decreasing the angle. It can also extend, which means we're increasing this angle at the elbow here. Now, the other actions that can occur at this joint here is pivoting. When we have pronation and supination. Of course, we can see on Mr. Bones here that when we turn our hand over, the head of the radius actually rotates and kind of glides and grinds in on that capitulum there. And so it's going to turn the hand over in for pronation or turn the hand back over for supination. And you can see how the radius starts here and actually turns and comes over the ulna during pronation. The next joint we're going to look at here is the joint between the humerus and the ulna. Get ready, it's a doozy again. It's the humero-ulnar joint. Pretty tough. So the humero-ulnar joint is the joint between the humerus and the ulnar, and the parts of these bones that come together are the trochlea of the humerus, and technically the trochlear notch of the ulna, but for sakes and convenience, we say this is part of the olecranon process. Remember, the olecranon process is that big bump that is your elbow, the actual bump that we feel to be the actual elbow. So this is what we call a hinge joint. All it does is flex and extend. We can see that the trochlear notch of the ulna here just glides in the trochlea of the humerus, and that's all it is. It's just on that one little track for flexion and extension. Flexion and extension. Now before we move away from these two joints, these proximal joints here, let's talk about some important facts or important structures here. Mostly with the humeroradial joint. There is a particular ring of cartilage that we want to look at called the annular ring. This is a circular ring of cartilage, annular meaning cyclical, right? A whole year's cycle, annular. Ligament, the annular ligament here is right around the head of the radius and helps with the articulation of the humeroradial and the radial ulnar joint, which brings us into the next joint. The radio ulnar joint is the joint between the radius and the ulna. The radius and the ulna meet, but they meet in two places. So we're going to have to differentiate where these two places are that they meet. One is proximal. Proximal meaning more closer to the body, to the trunk of the body. So our elbow is more proximal than our wrist, which is more distal. So we have the proximal radio-ulnar joint and the distal radio-ulnar joint. So when it comes to these articulations, the proximal radio-ulnar joint is the head of the radius with the ulna. The distal radio-ulnar joint is just the distal ends of those two bones. So the distal end of the ulna and the distal end of the radius. What occurs at these joints? Well, they are pivot joints. So this is where we really see that supination and pronation there. So this is where our hands are going to turn over and under here. So supination, hand is up. Pronation, hand is down. Coming down all the way to the wrist here, we have the joint between the radius and the carpal bones. Carpal, or carpi, referring to the wrist. The carpal bones are the bones in the wrist. And the radius comes down and meets them. And this is what we call the true wrist joint. The radiocarpal joint. This is your wrist joint. The radiocarpal joint. So this is technically a condylar type of joint. And what movements are allotted during this, at this joint? Well, we clearly know we can flex our wrists. This is flexion of the wrist. So if my hand was in anatomical position, flexion of the wrist is my fingers coming towards my forearm. Extension of the wrist is bringing my wrist backwards. So we have flexion and extension of the wrist, but we can also have deviation. We have two ways to deviate. So we're doing that little wave. So when we refer to deviation, we could have lateral or medial deviation, but more specifically, we would say we're deviating to the particular bone. So since our ulna is on the medial side of our body, which means closer to the center of our body, if our hands were to go like this, so if I was standing in anatomical position like Mr. Bones, my hand is down here by the side, this would be ulnar deviation. My fingers would be pointing towards my body. Then the opposite would be what we call radial deviation. I'm going towards my radial bone, which is the bone on the lateral side. So again, Mr. Bones here with his arm, this is radial deviation, ulnar deviation. Radial deviation, ulnar deviation. We obviously have a lot more ulnar deviation than we do radial deviation because of the big styloid process here on the radius. So to keep it simple when it comes to the carpals, obviously there's lots of joints in between each carpal, but we're just going to keep it very simple. If we had a joint between individual carpal bones, we just call that the intercarpal joint. We do have joints between the proximal row and the distal row of carpals, as we learned. We had a proximal row and a distal row of carpals, and we have a joint in between them called the midcarpal joint. So let's just look at what comes off of these carpal bones, what comes off of the wrist. So we would have the bones that were in your palm called the metacarpals, the metacarpal bones. So we have the carpo-metacarpal joint. Carpo for wrist, or the carpal bones, metacarpo, bone, and it's a joint. Or as we acronym it, the CMJ, or CMCJ joint. So the carpal metacarpal joint is a pretty fixed joint. We don't have much movement. I can't isolate my wrist and try to move the palm of my hand. It does not quite work. So coming out a little bit further, we'll find where the metacarpals meet our fingers, or those phalangeal bones that we talked about. So we have the metacarpophalangeal joint, the MCPJ, the metacarpophalangeal joint. The metacarpophalangeal joint happens to be a condylar joint with a lot of movement, because we can see that I can take my finger and do quite a bit of movements. I can essentially make a whole circular motion. So the possible movements at this joint are obviously flexion. If I ball a fist, that's flexing my fingers. If I extend my fingers back, that's extension. I can also abduct my fingers, spread them apart, or adduct my fingers and bring them together. So with all of those movements, then I can combine to have that little bit of circumduction. Obviously minus some of the rotation that would be necessary for true circumduction. So coming out from the metacarpophalangeal joint, the MCPJ, we have the phalangeal bones that stem out from the fingers. The interphalangeal joints there, or IPJ. So this would be the joints in between the individual phalangeal bones. So we have a proximal one and a distal one. So obviously the proximal one is going to be more closer towards the body, towards the trunk of the body. And then we have a distal one as well. These joints will only flex and extend. You cannot isolate at your large knuckle and try to adduct and abduct the bones, the joints right here in the very furthest part of your finger. It's just not going to work. So we have the distal and proximal interphalangeal joints. Now, backing it up just a step back to the metacarpophalangeal joint, we did have one that was very special in particular. The one metacarpophalangeal joint in particular we're talking about is the one at the base of the thumb. So this type of joint here is the only joint we see of this type in the entire body. It's called a saddle joint, which means there's a semicircle shape meeting with another semicircle shape, and they're doing this little dance, like two saddles coming together, like a horse saddle and then a rider with their spread legs coming on that saddle. So the first metacarpophalangeal joint, which is the thumb joint, is a saddle joint that allows for flexion, extension, adduction, and abduction, but most importantly, the biggest action that occurs at the thumb, our opposable thumb, is opposition, which means to bring the thumb, the pad of the thumb, to touch the pads of the other fingers, to bring our thumb across our hand. No other joint in your body can do what we call opposition. So just to recap very quickly, we have the humeroradial joint, which is the articulation between the capitulum of the humerus and the head of the radius that allows for flexion, extension, and that pivoting action that attributes to pronation and supination. The next joint was the humero-ulnar joint, which was the articulation between the trochlear notch of the ulna and the trochlea of the humerus, which only allotted for flexion and extension, being that it is a hinge joint. We then had the proximal radio-ulnar joint, which allowed for the pronation and supination, that rotation there, that pivoting action. And then we had the distal radio-ulnar joint, which was the articulation of the distal ends of those bones. Again, it allowed for that pivoting, the supination, pronation. We then had the radiocarpal joint, the joint that was between the radius and the carpal bones. In particular, we had the scaphoid and the lunate. And then that allowed for flexion, extension, and then that deviation, the ulnar and radial deviation. Obviously, if our hand is turning towards the ulna, that is ulnar deviation, and then if our hand is turning towards the radius, that is radial deviation. Then we had joints in between each carpal bone for the intercarpal joint. Then we had joints in between each row of the carpals, which was the midcarpal joint. And then we had a joint between the carpal bones themselves and the metacarpals of the hand. We had the metacarpophalangeal joint, or acronymed CMCJ, the CMCJ, the carpo-metacarpal joint, which didn't have much movement to it. We then had where the metacarpals meet the phalangeal bones, or the metacarpophalangeal joint, the MCPJ, which allowed for, in all cases except for the first, flexion, extension, adduction, and abduction. So the first had all of those movements plus opposition because it was the thumb. So the thumb was a saddle joint. The first metacarpophalangeal joint was a saddle joint that allowed for flexion, extension, adduction, abduction, and opposition. Then we met the fingers, or the interphalangeal joints, where we had a distal and a proximal. So we had the proximal interphalangeal joint, or IPJ joint, and the distal interphalangeal joint, which only served to do flexion and extension. Alright guys, that's going to do it for the joints and the bones and bony landmarks here. So go ahead, take your time to restudy this video, and I'll see you in the next one.